Okay, hello everyone. This is the second session that I'm trying to take for the POC that we saw in the first video about cumulative distribution function, which helps us get the probability of a machine of since in terms of time scale for failure. So if it has been already 1,000 hours since last breakdown, what is the probability? If it is 2,000 hours, what is the probability? And then it could pitch in as an input for my predictive maintenance story, which is a bigger story, where beyond a particular percentage, we could already trigger a notification for maintaining equipment and ensuring that the breakdown doesn't happen. So just quickly again an insight into what we did. In rounds manager, I have enhanced an equipment breakdown probability, which is from a complex table coming in, and as and when the values change based on the current time, it also shows me the equipment breakdown probability. And now I would quickly take you through the steps that we did technically to achieve this. So this is nothing but a complex table. So I have an equipment breakdown complex table being created. So for a particular equipment, it has the breakdown probabilities coming in, and that is what I use to enhance the screen. Screen again, obviously based on the designing and the UX guidelines, we could do a lot of creative and interesting stuff on the screen. Especially with SMP 3.0 giving us open UI, we could really think of native interactive charts to give us more sense. But then eventually the point is that on my device, while doing rounds, or while the people who are out there in PM world doing rounds, inspection, or working on work orders, should have this intelligence with them to get an idea of the equipment breakdown possibilities, etc., so that they can take more corrective measures upfront. Obviously, this is all connected into HANA, so we saw a quick diagram at the end of the session, so I would just start with that diagram and take it forward now one by one. So predictive maintenance system landscape diagram. Okay, so I would just open with paintbrush. Yeah, sorry for my mistake here, it's VWool and not VWool. So VWool. Yeah, that's what it is. So complex table comes from a table in the backend. So I have a backend table enhanced with equipment ID, hours since last breakdown, and probability of failure. This comes from the change framework. So whenever there is an equipment history changes, which means there are new breakdowns reported, etc., what I would do is I would use the enhancement framework capabilities and push that data and do a background job. What this background job will do is push this data into HANA tables and call a HANA procedure. What this HANA procedure will do is read this table values which are been pushed from the historical table, connect to the R server. In R server, we have a very powerful mathematical algorithmic possibility. So pvibul is one of the inbuilt function available. So we use this pvibul. It will return us a cumulative density function of the historical data that we pass. So it will give us against the hours. So in 5000, 5001, 5002, 1000, 1002, etc. So as of now, if we give range from 5000 to 10,000, it will give me for each and every hour what is the probability of this event. Event in this term being equipment failure to occur. So that I put it back into the HANA table for storage reasons, because I might want to use Access Engine and UI5 reporting or any other reporting directly from this data. So I also retain it into HANA table. But then what I do from Syclo perspective is that pull this data and also push it, pull this data from the enhancement framework back into the ERP tables. So then this ERP table, it has the data which is used for complex table in the mobile world. So this is how the things will keep refreshing from as and when the historical data keeps changing. So let's quickly see what all are the artifacts here. So in my agentry editor, I have enhanced a screen where I have put these values, and these values come from complex table. So I've created a complex table equipment breakdown probability, which has equipment ID, hours since breakdown, and probability. Java class obviously standard complex table, and in the backend what I have against these is some Barbie wrappers for complex table and the classes. So nothing much fancy here. So just let me search what I had with me. So Z, come on, equipment breakdown probability. So I just, as of now, I've not played around much for this POC. I just have get complex table, and I just take the values from the table, breakdown table, and put it into the thing. So how did the main thing over here is to understand how this table got filled. Yeah. So this table is getting filled from a background job. As and when the equipment details changes, we can fire a background job, which I have simulated currently in my ABAP report. I'll share the source code attachments in the jam session. Um, so what it does is it uses the secondary connection of ERP. This is to one of the HANA boxes which I'm using for POC, which is also connected to our server. So here I've used a standard select statement for notification coming up. This select statement is exactly from the standard reports of PM, which are used for calculating mean time between failures, for example. So I take all that data. I created a secondary connection to the DB connection name, whatever it is over here, and this connects to a particular HANA instance. I calculate the time difference between the last equipment breakdown to and from, and get the difference in time frame. So what I insert in HANA table is the breakdown details in terms of breakdown and hours since the last breakdown. So breakdown number 1 happened on so and so date, and hours since last breakdown was so and so. So it'll keep an count of steps in hours between last breakdowns. Once that is done, that is my push data. The second then I do is I try and simulate HANA. I could have written an entire HANA procedure and made one call, but I just wanted to simulate that entire step together over here. So as of now, what I do is I just clear some of the tables that I have in HANA. I insert into the history table details for this particular equipment which we just pushed. This history table is then being used for calling a function vbool1, or it could be vbool anything. So this is the function that I created in the backend in HANA, which is responsible to pass the control to R. Once this function is called, I just need to call material distribution or MTTR meantime to break distribution table. This is just the name that I give, which holds the result after running the module. So this then I take the data and I push it into my ERP table, which is used for complex table generation, which we just saw. So let's see what we have done in HANA box for this. So in HANA box, the PAI system is connected to an R server. So there is a sandbox. This is a sandbox PAL system given to us by the PAL team, and we also have our system which is connected to this, which is a sandbox system which we have got from the R team. So they helped us identify the modules, and they helped us identify which systems to get connected for our POC. So very thankful to them. And here what we have is in our catalog, don't bother about the SQL, that is the thing that we just executed over there. What we are interested in seeing so for the fitness distribution, seeing the procedures. So I've created a procedure vbool1 over here. What vbool1 does is, this is the heart of the entire algorithm, right? So what vbool1 does is only these few lines of code. What it tries to do is it takes the input. As of now I have hard-coded the values of the range for which I want to do the probability from 5,000 to 10,000. This could also be an input. So ideally, if your mean time between failure is at say 8,000, you could get the probability distribution around this. So you could get it from 4,000 to 12,000 or 0 to 16,000, something like that. So it depends totally on what is the need of the business, and we could pass this value also to this procedure, and then it will be taken dynamically. And then I call pvbool method, which I just showed you on the PPT. It gives me the probability distribution, yeah, and then this probability distribution is something that I pass back into the out table, which is the KS test and the material distribution. The test table is more on the statistical information of how the algorithm ran and what are the fitness values, etc. But for us, important is the distribution table. This distribution table is so these are the tables that I used. So this is the table where we send data from the backend, and these are tables that get so-called. So this table is then per equipment put into a history table. History table is used to run the vbool function, and then it gives me the distribution. Distribution, I read it back and then put it into my ERP table for that equipment. So these are more or less like the temporary tables for me. Of course, I could store the history table in the ERP in the HANA stack for further reporting as well. So, well, that's pretty much about it on what we have tried to do. So it's all Syclo to ABAP to HANA to R and back all the way. And as I mentioned, this is our first breakthrough into the predictive maintenance bigger story. So if you have any questions, please let me know. I'll be more than happy to answer. Thank you.